of x is given to be x squared plus 1. Now we're going to apply the limit definition for derivatives. Limit delta x approaching 0, f of x plus delta x minus f of x over delta x. Okay? So did you guys do this? X plus delta x. So now, x plus delta x the whole squared, you either use your special products. Remember, a plus b the whole squared is a squared plus 2ab plus b squared. But if you don't want to do that, you do the regular part also.
What happens to the x squared?
So instead of the x squared, so you do this or this, okay? The x squared, in place of x squared, we have substituted x plus delta x. Because we are going to apply this formula. The definition of the derivative. So now, x plus delta x squared, when you expand it, what are you going to get?
X squared plus 2x.
2x delta x plus, correct, plus 1. Please check if this is what you have for f of x plus delta x. If you did not, so let's try the FOIL method. If you, which one did you prefer using? The special product? Okay. Either way, okay? So if you're using special products, A is x and B is delta x. So a squared will be x squared plus 2 times x times delta x. I'm just substituting for A and B. Plus B is delta x squared. Plus 1. Plus 1 is because the 1 is there in the equation. Is that clear to you? So that is f of x plus delta x. Now you substitute in the limit definition of derivatives and you get x squared plus 2x delta x plus delta x squared plus 1. So this whole thing is f of x plus delta x. Follow it? Yes. Minus f of x is given to be, so please make sure you're putting the parentheses every single time. Minus x squared plus 1. Because that is my f of x. Are you following? So we substituted for this from here, and then we are substituting for this from the given equation. Yes?
So something in the problem, the first thing you should do is find f x plus delta x.
Correct.
By special products or
Depending on what the problem is. So sometimes it's a direct substitution. Sometimes it is this. Say sometimes it is a trig function, it's something else. So depending on what that is. Now whole thing divided by delta x. So limit as delta x approaching 0. Now, so once we get to this point, any questions so far? You okay? So what do we do next? Correct. Distribute the negative. So this is to substitute, and then after that you got to distribute the. So I will say that simplify. You get x squared plus 2x delta x plus delta x squared plus 1. And now when I distribute the negative sign, I get negative x squared. And then minus 1. Get it? The whole thing divided by delta x. Limit delta x approaching 0. Okay? Now, when you cancel like terms, what will you end up getting? So 2x delta x plus delta x squared is what you're left with, divided by delta x. Hold on. Now so you got this point, right? So you cancel, any questions about the canceling part? So you cancel these two, and the 1 and the negative 1, and this is what. Okay? Now the previous problem you solved, your delta x, everything got canceled, right? But here we have delta x, and we need to apply the limit. Okay? So I want you to look at the numerator. Tell me what you can do about it. Correct. So you can factor out the delta x. So you see this? limit delta x approaching 0. Let's factor out the delta x approaching 0. What will I be left with? In the numerator. I'm factoring a delta x because there is one here, there's a square. 2x plus delta x. Because there are two delta x's, you can have 1 divided by delta x. It's not 0 yet. You factor it. What am I doing? I'm factoring the numerator. The reason is because when I apply the limit at this point, you see, if I apply the limit, I'm not going to have 0 over 0. But we go back to the basics of limits, where you're seeing if you can factor out something and simplify. So now what happens to this expression?
So you're not going to hold same on top?
Yes, you factor the whole thing now, you cross these two out. You cross the delta x out, and you end up getting limit delta x approaching 0, 2x plus delta x. Because see, when it's inside, it's a product. So remember, we can only do whatever we're talking about. Now you apply the limit. What do you get? 2x. That's it. So the limit, the derivative of x squared. So f of x is 2x squared plus 1, right? F prime of x is going to be 2x.
So you don't know that, wait, someone's trying to do that already? Oh, no.